Greetings, math friends. We are going to look at doing a square root by hand. When I first learned to do this, we used apostrophes to group this, but I'm going to use a different technique here. Your first step is to group your numbers in sets of 2. If you're missing a number to have a set of 2, you're going to fill in a 0 with that. So just over to the side, I'm going to write 1296. I just get a little space between those, and I'm going to put a line above it. And I want to look at what is the square that is closest to this number. If we look at 3 squared, that's going to be 9. If you look at 4 squared, that's going to be 16. So 3 is going to work here. So I'm going to put 3 up here, and then I'm going to subtract the 9 from this. So 12 minus 9 is 3. And then I'm going to take the number that I put on the bar and multiply it by 2 and write that out here with a space. So 3 times 2 is 6. We bring down the 96 here. So I want to look at some number starting with 6 in tens place that divides into 396, like the idea of long division. So this is going to be a 2-digit number eventually, and we have to find what number we're going to fill in here. It seems a little convoluted, but it will end up working. 6 won't go into 3, but 6 will go into 39. 6 will go into 39 6 times because 6 times 6 is 36. So we're going to fill in a 6 here. So we're really looking at 66 divided into 396. And we're also going to write a 6 up here over the 96. So we write the 3 over the 12, and we look for the closest square going into 12. And then as we bring down 96, we add this 396, which is the remainder here, plus these terms. We're going to divide 66 into this. So it turns out 66 times 6 is going to be the number that we need. So over to the side, let's do some side work. 66 times 6. We get 396. That's exactly what this is. So 396, we subtract, and we have 0. So this number up here above the bar is actually our solution here. So the square root of 1296 is 36. So this is actually a perfect square number. 36 times 36 is 1296. So that's nice when it works out well like that. What happens if you don't have a perfect square? Most of us are probably experienced enough to know that this is going to have some decimal expansion. So that's the next example that I'm going to look at. And with those decimal expansions, you typically have an irrational number, which means those decimal expansions will go on forever. They won't have any set pattern, and they're not going to self-terminate. So you're going to do that process as long as you need to get the accuracy that you're looking for. So we are getting as an exact solution as we can according to the level of approximation that we need. So the textbook that I am working from today is this textbook from 1957. This is an Algebra 2 textbook, and there's a lot of wonderful information that is in this textbook that was taught back in the 50s that at this point I think some of my students in modern times would feel was beyond what they would like to see in an Algebra 2 course. There are proofs in this book which in modern times we tend to see that relegated only to high school geometry and not necessarily carry over into our Algebra 2 class, although it certainly can be there. And we also don't see people doing square roots by hand anymore. We have a lot of technology. At this time, if people wanted an alternative to doing this by hand, you may either be using a table of values or a slide rule. But this is kind of a fun technique that has kind of been lost to history for a lot of people, but we're going to go ahead and continue on with this. I was thinking about this book today because I had been watching some YouTube videos earlier, and I saw Mathematical Toolbox talking about if there were a fire, what textbooks would he save? And it made me think of this book, which was a gift from a family who had a family member that was a math and science teacher, and they asked me if I was interested in some of his professional library, which I certainly was. This is a beautiful book. I also saw another channel talking about how to do cube roots, and some people were disappointed with the demonstration there. So I'm looking at square roots. I first learned to do square roots probably in two different algorithms when I took the history of mathematics back when I was working on my undergraduate degree. We're going to do the same setup. We don't necessarily know when to anticipate the decimal expansion here unless you've memorized a lot of square numbers. So again, we're going to do separate this into two sets of 2, and I'm just writing this bar over here just to keep track. And I need a number that is the square closest to 54. So if we look at 5 squared, that's 25, that's half of that. 7 squared is 49. Not going to get much closer than that. If you look at 8 squared, of course, that's 64. So definitely 7 is where we need to land. So I'm going to write my 7 up here. I'm going to subtract the square of 7, which is the 49 here. And this difference is going to be combined with this number that we bring down here. So I'm looking at long division kind of at this point. I'm going to multiply this number by 2. And then I need to fill in the 1 space. I'm going to look at 14 into the 51 first, and that's what number I'm going to fill into the 1 space here. 14 into 51. If we do 14 times 5, we get a 0 here, and we get 70 there, so 5's too big. 14 times 3, we get 2, and then 4, we get a 42. If you add 14 to that, you see that's going to be bigger than 51, so this is the number that we need to land at. So 3 is going here, 3 is going here, and then if we multiply this by 3, we're going to be subtracting. So 9 minus 16 is 7. We're going to have to borrow here, so 10 minus 2 is 8. So I have 87 here. Now, I don't have any more numbers here to bring down, so that's where I fill in zeros. So bringing down, I'm bringing down 2 zeros. Remember, we're doing sets of 2. I'm going to take this 73, and I'm multiplying it by 2, just like I multiplied the 7 by 2 here. And I'm going to, again, leave space here to fill in that 1 space. So I have 146 here, and I need to see how many times that's going to go into 870. I'm going to go ahead and try 7 first. 7 times 6 is 42. 7 times 4 is 28, and we had to add 4 to that, so that's 32. 7 plus 3. So we see that's 1,022. That is too big. So looks like 6 is probably going to be our number. It actually comes out just a hair too big, so 5 it is. So with this, your times tables have to be really excellent, or you're going to use a calculator to assist you. But if you're using a calculator to assist you, then you maybe aren't doing square roots by hand. You have to know what your goals are. With learning just this technique, if you need the help with the times tables or whatever, you maybe have that just to help you along. Um, 30, 20, 5, 6, 7, 730, oops. So I'm going to take 5 times this number. That's going to give me 7,325. I'm going to subtract that out. I'm adding a decimal here because these zeros that I added in were extra, so that's where the decimal place goes. So right now I'm looking at the square root of 5,416 being 73.5 something. All right, so then we need to subtract this out. That's 3 and 1. That's a pretty big number. Remember, I'm going to have to bring down some zeros here as well. So I'm looking now at, I need to divide into 138,500. We're going to ignore this decimal point here and multiply the 735 by 2. That's going to give us the 1,470. The closest that we're going to get to 138,500 is multiplying the 1470 by 9, and we get the 13,230. I'm going to put a 9 here, put a 9 up here. So we're going to multiply this by 9. So we're going to add over here 81. So we have 1, 3, 2, 3, 8, 1 here that we're going to subtract out. And again, we're anticipating that this is an irrational number, so this process is going to keep going on. I'm going to keep generating these decimal values, and it's not going to stop. So you have to know where you need to stop. A lot of times textbooks say round to the nearest tenths place. Wherever you need to round to, you need one decimal place further than the place that you need to round. So in this case, I could stop now if the directions are to round to the nearest tenths place, because I have the tenths place here, the hundredths place here. The hundredths place indicates to me where I need to round the tenths place. So my estimate rounded to the tenths place would be that this is approximately 73.6 is the square root of 5,416. However, this is an approximation. That's why I have the squigglies here, because you're not going to get a terminating number here if this is an irrational number. So again, you have to know where you need to stop. And those should be directions given in one way or another. If you're in a classroom, they typically say round to the tenths or the hundredths place. If you are working in industry, which you most likely will have some pretty decent computing power in that industry, there's an industry standard where you're going to round, whether it's the 5th decimal place or the 8th decimal place, or somewhere lesser than that. Hopefully this has been an interesting look at a lesson that is not typically currently taught in a lot of mathematics classrooms, just because technology has put us in a position where this is seen as an unnecessary skill set now. Be patient with people, and if you're in an area where you have a freedom to learn and discuss things, exercise that right. Use a library, use the internet. Old textbooks like the one I'm referencing today are wonderful. Cheerful Calculations.